So today is the last day of the key features sections. So we know how to find our key features, which are domain, range, the x-intercept, the y-intercept, the slope, if we're increasing or decreasing, all that jazz. We have practiced getting it from equations. We've practiced from getting it from graphs and from tables, okay? Today we're going to kind of compare all those together. So see, number one, I have a list of equations. I have 3 lines being graphed, and I have 3 tables. So they're kind of all there, and we're going to see what can we pick out from each of those items. Okay. What form of line is A written in? What kind of a line is this? If X and Y are on the same side. Standard form, good. What form is B written in? Whoops. Slope, intercept, good. Which one of those is the slope? 1/2, 1/2, good. What intercept is -3? It's the y-intercept, yep. And now what form is line C written in? That is point slope, good. What's the slope? 1/2, good, 1/2. And what is the point? Careful, points are written as x, y. There you go, 6 and 4. Remember, this is x minus x, right? So x by itself is 6. This is y minus y, so the y by itself was 4. All right, so looking at those, we are trying to connect them all together. So which one of those graphs, which one of those tables matches with equation A, B, or C? Okay, I want you to try to see if you can pick them out, okay? I'm going to give you a couple of minutes. The colors, I know there's no colors on your paper. The colors are up here, and I'll zoom in. Try to pick which graph and which table goes with equation A, which graph and table goes with B, and which graph and table goes with C. Okay? Just try your best. I'm going to pause this. All right, let's try to talk it out together. Okay? Do you want to go from equations to tables, or do you want to do equations to graphs? Some graphs, some tables. I personally would go to the table just because I can plug stuff in from the table. Okay. So look in here, because we already know 0.64, but that's not on any of my tables. Okay. What do we know about A and B? I see that they both have a y-intercept of -3, right? Okay, so that means it's going to have to be 1 or 2. My slope is different. How is the slope moving for part B? Going up 1 and over 2, right? Okay. Remember how yesterday we plugged stuff in? We can do that, okay? Looks like they all have a different, and let's pick an easy number. Look at an x value of 1, right? For all of my tables has a different outcome, right? So let's plug in an x value of 1 into our equations and see which outcome we get, okay? Because see how it was kind of hard because y-intercept, some of them match. The slope, some of you that might be hard to see in a table, okay? So I'm showing you all the different ways that your brain could be going through. You don't have to give up because you don't see it right away, okay? So let's plug in the number 1. Which equation do you want to plug it into first? Which equation? A, B, or C? B, okay, let's plug it into B. So we have y equals 1/2 x minus 3, okay? So y equals 1/2 times 1 minus 3. What's 1/2 times 1? 1/2. And what's 1/2 minus 3? Use your calculators, do not guess. -2.5. So Is equation B matching up with table 1, 2, or 3? Table 1. See that? Because we plugged in 1 and we got out negative 2.5. So those match up together. All right, I could probably go ahead and match that up in the graph. What color line is that going to match up with? Well, careful, my slope is a positive, right? Positive 1/2. So it has to be orange or purple. Okay, it has to be one of those. Okay, question. Was my y-intercept, so look at the difference. Was my y-intercept a positive or negative number? Negative, right? Orange is above the origin, so that's going to be a positive y-intercept. So it's going to be purple. Yep. All right. So we got equation B figured out. So let's plug 1 into one of the other ones. Which one do you want to do, A or C? A. All right, so let's plug it into A now. Yep, we're going to plug in. So instead of 4 times x, we're going to do 4 times 1 plus y equals negative 3. All right, what is 4 times 1? 4. So now we have 4 plus y equals negative 3. Now what are we going to do? Subtract the 4. So y equals negative 7. So that matches with which table? Number 2. So by process of elimination, C has to match with table 3. All right, now let's figure out my graphs. Orange is increasing, green is decreasing, right? So if you look at your equations over here, equation A, equation C, which one of those tells you the slope? We're not looking at B anymore. We already used it. C has a slope of what? Of 1 over 2. That is a positive 1/2, right? So is that going to be the orange line or the green line? It has to be the orange line. Good. So C is orange, which means A goes with my green line. All right, so we use different key features. What did we mostly use for these guys? So we definitely used y-intercept to help me with purple, right? That's what helped us figure that out. What else did we use? We use slope, right? We use slope a lot. So we knew my y-intercept was, because first we figured out it was a positive slope, so we narrowed it down to orange and purple. And then we figured out a negative y-intercept, so it had to go under, right? All right, to determine between the green and the orange, what did we use? We used slope again, yeah, because one was going up and one was going down. Okay. Absolutely. Good. We good? See how we can kind of use the tables graphs to help connect them all? Yes, ma'am.
Why did you pick the 1? Like, was that just like a random pick?
I picked, so 0 is a nice number. We had to plug something in. Let's start back. We had to plug something in to kind of figure out what the outcomes were going to be, because us just looking at it wasn't computing in our brains. Okay, so plugging in 0 would have been great. My issue is 1 and 2 have the same outcome, right? They both give me a negative 3. So plugging in 0 wouldn't have determined which equation it was going to match with. Okay, but my next easy number to plug in is the number 1, and they all had different outcomes. So that's how we picked the number 1. You can plug in anything, but that's why I picked the number 1. Yes, sir. Can you what? Sure. Yeah, you could then negative 2 because your outcomes are nice whole numbers. Is that what you see? Yeah, that's fine. You could have done positive 2. Those are all nice whole numbers also. You can do whatever number you want. I just didn't pick 0 because it had the same outcome for 2 of them. All right. Questions on that one? Because now we're going to kind of relate it to some real world stuff. Okay, and let's make sure our answers make sense to certain things. So we have Bella. She's using a gift card to buy coffee at a coffee shop. Let's say Lucky Gift. The initial value of the gift card is $20. The function A of C equals $20 or 20 minus 2.75C. Okay, this represents the amount of money, which is the A, in dollars that is still left on the gift card after purchasing C cups of coffee. So A equals the money amount, C equals cups of coffee. So they gave me a graph, they gave me a table, and it wants me to figure out the key features of this. Does my line go forever? No. So we're not going to use infinite, which really, that should make sense in your brain because we're talking about real world stuff, right? Money and coffee. Unfortunately, there is no infinite money or coffee. It would be great if there was, wouldn't it? Man, my life would be made. Okay, so it makes sense, especially since she's using a gift card. She's limited to what she can buy. Okay, so my domain, what is the lowest? So my X is here. My inputs are my cups of coffee, right? So what's the lowest amount of cups of coffee she can buy? 0. Okay. According to the table and according to the graph, what's the most amount of cups of coffee she could buy?
17.25.
Look at the most. 7.27. So that one, it showed it, my table showed me the ending. What are you talking about, baby?
At the very top of A, it says 20.
Right, that's the money. These are my Y's. We're looking at my domains. So what's the least and the most amount of cups of coffee we can buy? That's our input. Okay. Range is going to be the money, right? So what's the lowest amount of money I can have on my card? 0. And what's the most money we can have on our card? 20. So we can't spend more than $20, right? And we're not going to spend negative money. That doesn't make sense either. So here to here. All right. As x's increase, what's my line doing? It is decreasing. Again, make it make sense. If you're spending money, isn't it going to go down? The balance on your card, it makes sense. Make your math make sense. All right, my slope. So we know it's going to go down, right? Because we're decreasing and we're spending money. But how is it going down? Where'd you get that from? Yeah, you could use the slope equation if you wanted to in the table, but our equation, right? This is slope intercept form. It gave us the slope. So we have a function, a table, and a graph. So use all of those things to help you. Okay. So it told me my slope was negative 2.75. Okay. What does that mean, by the way? With my coffee. Here you go. Each cup of coffee is $2.75. Good. All right, here we go. So, x-intercept. So an x-intercept is when what piece is 0? When my y is 0. So what's our x-intercept going to be? Good, 7.27. All right, and my y-intercept is when what piece is 0? When x is 0, yeah, so what's my y-intercept? It's going to be 20. Good job, guys. It just means it's repeating. You can put that on there, yeah. 7.27 repeating, yeah. Thank you. We good? So even though I put words to it, are we okay? In reality, come on, cups of coffee and money. We're okay with understanding what the numbers mean now. Now the numbers have meaning, okay? So because we're talking about a real thing, okay, the domain is the complete set of possible values depending on the context, okay? The domain may vary depending on the context. The domain of the function should really only be whole numbers of 7 or less. Okay? Why? Why should I have indicated that it could only be whole numbers between 0 and 7? Yes, you can't do cups. You can't do partial cups of coffee. So this content refers to cups of coffee. So you can only buy 0, 1, 2, 3, 4, 5, 6, or 7 cups of coffee. Technically, that should be our domain for this, because we're talking strictly about cups of coffee. Okay. So if I was really showing a graph for this real life situation, would you connect the dots? You would not connect the dots. You would just have the points of 1 cup of coffee, 2 cups of coffee, because connecting them represents parts of a cup of coffee. Okay, so in this context, if I was drawing a real graph to represent this real situation, you would not connect them. All right, a little bit more about our coffee. Okay, complete the interpretation of the slope of the function. Okay, for every blank cups of coffee purchased, the amount of money still up on the gift card increases or decreases by blank amount. So you and your partner, see if you can if you can check off the boxes. All right, talk to each other. All right, so I asked for you just to try, and everyone did. Okay, so here we go. Complete the interpretation of the slope of the function. So our slope was the negative 2.75c, right? So that means for every, how many? Every 1 cup of coffee, the amount left on the card is going to decrease by how much? 275. Good. Now, let's interpret the y-intercept. Okay, what does the y-intercept indicate about the card, the gift card? Good. The y-intercept was 20. So that means it is the original amount of money on the card. That's what you start with. Original amount on your gift card. So y-intercepts are, when it comes to real world stuff, that's where you always start. Later we'll have examples of like doing quadratics, dropping things off of a building. Your y-intercept's going to be how tall the building is. Something like that. Okay? Or a bird left a tree to swoosh down and get a fish. Your y-intercept is how tall that tree was. Okay? It's always where you start. All right, number 6. The x-intercept for the function a of c equals 20 minus 2.75 is not viable for the context. Explain why the x-intercept does not make sense for the contents. There we go, because what is our x-intercept? 7.27 or whatever?
Yeah.
And we already talked about my domain has to be whole numbers. We can't buy a part of a coffee. Can't buy partial cup of coffee. Good. Partial cup of coffee. You either have a cup of coffee or you don't have a cup of coffee. The cup exists or it doesn't exist. No matter how much is inside of that cup, you either have the cup in your hand or you don't have a cup in your hand. That's still a cup, right? It's still physically a cup in your hand. It's still a cup in your hand. It's a damaged cup, but it is still a cup in your hand, right? Okay. Are we good about the coffee and the gift card and all that jazz? It made sense.
Yeah.
Okay, cool. We are not doing this today. We're going to come down here. I want to give y'all time to work on your practice. So we're just going to do one more real world stuff. This is about marbles and a container. Okay. So Antonella places X marbles into an empty container. Each marble has the same weight. The weight in ounces of the container and the marbles can be used, oh my gosh, I can't talk, can be found using the equation W of X equals 3X plus 8. Okay, they have graphed it for us. I know it's kind of faint on your paper. This y-intercept is 0.8, which was written for you in your table. The x-intercept as a decimal, it's negative 2.66. In your table, it's written as a fraction, and that's fine also. Okay. So Lee completed the table of 4 key features. Determine if the key features given, if they're viable or not. Okay. So we're focusing on the viable part. Okay. So viable means does it make sense? So in this case, does it make sense about the amount of marbles and the weight of the container? Okay, so hold on. We're going to do it for each different piece. So she says the domain is x's are bigger than 0. What did x represent? What did it tell me? X equals marbles. So does it make sense that the amount of marbles I have can be 0 or more? Yes. Okay. Because this indicates we can't have negative marbles. Does that make sense in real life? Yes. So can't have, I'm going to say negative M, negative marbles. Okay. So yes, this makes sense. What's that? But you can't have negative marbles. It's not possible. Don't you play the what if game. Nobody wins the what if game. Don't play. Everyone loses. All right, my range says y's have to also be bigger than or equal to 0. What was my y's representing? So my y's were the weight. Good. So does it make sense that my y's can only be 0 or more? Yes. Because we can't have negative weight, right? Right. Good job, guys. Can't have negative weight. Is it possible to have a weight of 0? Yeah. If you have no marbles, the weight is probably going to be 0, right? All right. X-intercept, negative 8 over 3, comma 0. No. How come? That's one of the, yeah, so we can't have a fraction of a marble. Good. What else? Oh, you can't have a fraction of a marble. What else is wrong with that number? And it's negative. Okay, so there's 2 things wrong with this. It's a negative number. We just said we can't have negative marbles. And it's a fraction. We can't have a partial marble. So you either have it or you don't. Don't say if it's broken. We're not doing that. Either you have a marble in whatever condition it's in, or you don't have a marble. Okay, so you can't have negative marbles, and we can't have partial marbles. Sorry, those spaces are so small. All right, my y-intercept of 0.8.
No. Yes. You can't have a weight with nothing. Yes, you can. If you don't have no marbles in your head.
So what is this showing? So what weighs 8 ounces if I don't have marbles? Read it. Antonella places X marbles into what? A container. So the container, good. My container weighs 8 ounces. That's what that's showing. It means I haven't put marbles in yet.
What's the word right there?
Negative marbles, partial marbles is the reason why our x-intercept is not going to work. So this, our y-intercept, yes, this is viable. This is showing that if I have 0 marbles, the container is 8 ounces. Oh, that's not the number 8. There we go. So remember we talked about our y-intercept is the beginning, right? So that's the beginning weight. Before I put marbles in this container, it weighs 8 ounces. So does it make sense that my graph is increasing? Yeah, if I put in more if I put in more marbles, my weight's gonna go up, right? So the graph makes sense. Good. All right. We okay with real world bringing it all together? Okay. Please open your workbooks to page 73.